When performing load calculations for residential electrical systems, a common question arises concerning refrigerators and small appliance branch circuits. The answer is no. A refrigerator is not typically included in the required 220-amp small appliance branch circuits that serve the kitchen, pantry, breakfast room, dining room, or similar areas. The National Electrical Code, or NEC, provides specific guidelines for these circuits, outlining what is permitted and required. Small appliance branch circuits are intended to serve countertop appliances and other portable devices. They are typically 20-amp circuits using 12 American wire gauge, or AUG, wire, and they must be installed in the kitchen and other areas mentioned. The purpose of these circuits is to provide sufficient power for the various small appliances commonly used in these areas, such as toasters, blenders, coffee makers, and the like. Refrigerators, on the other hand, are generally considered to be dedicated appliances and are typically installed on their own individual branch circuits. This is primarily because refrigerators have a continuous load characteristic, meaning they operate for extended periods and require a consistent power supply. Additionally, refrigerators often have higher power demands than typical small appliances, particularly during startup. Therefore, installing a refrigerator on a dedicated circuit helps to ensure that it receives adequate power and does not overload the small appliance branch circuits. Now let's delve into the specifics of the National Electrical Code, or NEC, and how it addresses refrigerators and small appliance branch circuits. The NEC provides detailed requirements for branch circuits, including the number of circuits required, the ampacity of the conductors, and the types of loads that are permitted. The NEC specifies that at least two 20-amp small appliance branch circuits must be provided to serve the kitchen countertop and similar areas. These circuits must be wired with 12 American wire gauge, or AUG, wire and must be installed in accordance with the NEC requirements for wiring methods and overcurrent protection. As for refrigerators, the NEC does not explicitly require them to be installed on a dedicated circuit, but it is a common practice and often recommended. The NEC does require that all appliances be connected to a branch circuit that is capable of supplying the appliance's rated load. This means that the branch circuit must have sufficient ampacity to handle the refrigerator's continuous load, as well as any additional loads that may be connected to the circuit. In most cases, a dedicated 15-amp or 20-amp circuit is sufficient for a refrigerator, depending on its size and energy consumption. It is important to consult the refrigerator's nameplate to determine its specific electrical requirements. The nameplate will provide information on the refrigerator's voltage, amperage, and wattage, which are essential for selecting the appropriate circuit breaker and wire size. When installing a dedicated circuit for a refrigerator, it is important to follow all applicable NEC requirements. This includes using the correct wire size, installing the appropriate overcurrent protection, and ensuring that the circuit is properly grounded. Additionally, it is important to consider the location of the refrigerator and the proximity of other electrical outlets. The NEC may require ground fault circuit interrupter, or GFCI, protection for receptacles located in certain areas, such as near sinks or water sources. In some cases, it may be permissible to install a refrigerator on a general-purpose branch circuit, but this is generally not recommended. General-purpose branch circuits are typically used to supply lighting and other small loads, and they may not have sufficient ampacity to handle the continuous load of a refrigerator. Additionally, connecting a refrigerator to a general-purpose circuit can increase the risk of overloading the circuit, which can lead to nuisance tripping of the circuit breaker or, in more severe cases, electrical fires. Therefore, it is always best to install a refrigerator on a dedicated circuit whenever possible. This will help to ensure that the refrigerator receives adequate power and operates safely. Now let's address some common misconceptions about refrigerators and small appliance branch circuits. One common misconception is that all refrigerators must be installed on a 20-amp circuit. While it is true that some larger refrigerators may require a 20-amp circuit, many smaller refrigerators can be adequately served by a 15-amp circuit. The determining factor is the refrigerator's electrical requirements, as indicated on the nameplate. Another misconception is that refrigerators can be plugged into any available outlet. As mentioned earlier, it is important to ensure that the outlet is connected to a branch circuit that is capable of supplying the refrigerator's rated load. Plugging a refrigerator into an overloaded circuit can create a fire hazard. Finally, some people believe that ground fault circuit interrupter, or GFCI, protection is not required for refrigerator circuits. While it is true that the NEC does not explicitly require ground fault circuit interrupter, or GFCI, protection for all refrigerator circuits, it may be required in certain locations, such as near sinks or water sources. It is important to consult the NEC and local codes to determine the specific requirements for your area. In summary, when performing load calculations for residential electrical systems, remember that refrigerators are not typically included in the required 220 amp small appliance branch circuits. Refrigerators are generally considered to be dedicated appliances and are typically installed on their own individual branch circuits. This helps to ensure that they receive adequate power and do not overload the small appliance branch circuits. Always consult the NEC and local codes for specific requirements and recommendations regarding refrigerator circuits. By following these guidelines, you can ensure that your electrical system is safe and reliable. Additional considerations include the energy efficiency of the refrigerator. Modern refrigerators are designed to be more energy efficient than older models, which can reduce their overall power consumption. When selecting a refrigerator, look for models that are Energy Star certified, as these models meet strict energy efficiency guidelines. Also, consider the placement of the refrigerator in your kitchen. Avoid placing it near heat sources, such as ovens or dishwashers, as this can increase its energy consumption. Ensure that there is adequate ventilation around the refrigerator to allow for proper heat dissipation. Proper maintenance is also crucial for ensuring the efficient operation of your refrigerator. Regularly clean the refrigerator coils to remove dust and debris, which can impede heat transfer and increase energy consumption. Check the door seals to ensure that they are airtight, as leaks can allow cold air to escape and increase energy consumption. By taking these steps, you can maximize the energy efficiency of your refrigerator and reduce your overall energy costs. Furthermore, understanding the different types of refrigerators available can help you make informed decisions about your electrical needs. There are several types of refrigerators, including top freezer refrigerators, bottom freezer refrigerators, side-by-side refrigerators, and French door refrigerators. Each type has its own advantages and disadvantages in terms of storage capacity, energy efficiency, and electrical requirements. Top freezer refrigerators are typically the most energy efficient and have lower electrical requirements. Bottom freezer refrigerators offer more convenient access to the refrigerator compartment, but may consume slightly more energy. Side-by-side refrigerators offer a larger freezer capacity, but may have narrower refrigerator compartments. French door refrigerators combine the features of bottom freezer and side-by-side refrigerators, offering both convenient access and ample storage space. When selecting a refrigerator, consider your specific needs and preferences, as well as the electrical requirements of each type. Also, be aware of the potential for power outages and consider installing a backup power source, such as a generator or uninterruptible power supply, or UPS, to keep your refrigerator running during an outage. This can help to prevent food spoilage and ensure that your refrigerator continues to operate safely. In conclusion, the electrical installation of a refrigerator requires careful consideration of the National Electrical Code, or NEC, local codes, and the refrigerator's specific electrical requirements. By following the guidelines outlined in this discussion, you can ensure that your refrigerator is installed safely and efficiently. Remember to always consult with a qualified electrician for any electrical work and to obtain the necessary permits and inspections.